Okay, so hello and welcome to the last question we have for the week number 8 in the Machine and Mechanism 8 tutorial. So the example we have right here is about two disks are moving together with a certain value of omega. So two disks each have the mass of 30 kilograms are connected together using the belt which is subjected to a tension such that it does not slip at its contacting surfaces. You can see that we have the radius is also given, we have the mass, so we can find the I value very easy. Now, we have a torque here. So if the motor supplies a counterclockwise torque, having the magnitude of the M is equal to 12 T Newton meter, where T is going to be in second. Bear in mind what will be the angular velocity of each disk 3 seconds after the motor is turned on. Initially, the system was at rest, so that means that the omega 1 is equal to 0. So we'll start from these facts and try to find the solution. So let's go up with the free body diagram to explain more. But before that, we're going to show you the given answer to us. So we have the free body diagrams, so this should be drawn first. For disk A, is going to have the angular momentum, the angular impulse equation, the hc1 plus the sigma of the moments around the point C to dt is equal to the hc2. So we have the stage 1 and stage 2, and we need to find the moment. We know that it was at rest, so this value will be equal to 0. For this B, we're going to have the same equation, but the moment is going to be around the point D. Note that the omega A 2 is equal to the omega D2 because the diameter of the both are the same, so the omega should be the same if we ignore the losses. We can eliminate the integration of the T1 dt minus delta, the integration of minus the integration of the T2 dt between the two equations and solve for the angular velocity to find the omega 2 to be equal to 115 radian per second. So we start first with defining the problem. We have two disks in one system. Each of them undergoes the rotation about the fixed axis through the point A and D respectively. And the free body diagram will show us that the disk 1 is going to have the moment here, two reaction forces at the point C, which is not actually going to be affecting too much because they are not going to do any effect on the moment. The same thing for the weight. But the tension 1 and tension 2 will do. Okay, same thing. The T2 is equal to T2 on the other side. So we can write down individual equation for that when we can simply get into equalize them and we're going to find the answer. The difference is on that side we have the moment. We don't have the moment here because the motor is connected at A. So once again, I just resketched the free body diagram. Again, to put that the masses are known, the omega 1 is known to be 0. The moment or the torque is going to be equal to 12 T Newton meters. Delta T is 3 seconds, so T0 was 0. T1 is 3 seconds. The magnitude we have that the T1 is equal to T1 prime, T2 is equal to T2 prime. So now we're going to know that the omega A2 is equal to the omega B2, and this will be equal to omega 2. Actually, this should be C, but anyway, it doesn't matter. The equation we're going to have for the first one, the angular impulse equation as written, and the same thing is going to be for the other side. Difference will be here. Difference will be here because I can tell for the same mass, for the same radius, the IO will be the same. So we are going to have here that the IO omega 2, here IO omega 2, but here we're going to have the torque and the moments. Here we are going to have the moments because we don't have a motor on the second disk. So considering each disk separately, but we're going to have the same value at the end. So we'll come to the scenario for the disk number 1. We can see that the SC1, which is the I omega 1, is going to be equal to 0. Here, we're going to have the I omega 2, or the IC omega 2. Here, we're going to have the torque, plus this moment, the T1 times the radius, minus the T2 times the radius. Okay, so that's what we're going to do. Okay, so the IC omega 1, this will go to 0, 0 to 3, the torque, which is 2t as 12t to delta t, and here we're going to have the T1 or the tension 1 multiplied by the radius. This is positive because it's going to go to the counterclockwise, minus the second one, which is the T2 multiplied by the radius, and this will take us to the clockwise direction. It's going to equal to the IC omega A2. Now we can find the IC, and we know this one is 0, so the equation can be simplified to be as following. This will be the equation 1. I can do actually further by do the integration for those because I know it's 0 to 3. But in all the cases, you will find out that on the other side, this will be subtracted and is going to be eliminated. So we go to the side B. In the side B, we're going to have the HD1 and HD2, which is the I omega 1 and I d omega 2. And here we're going to have only the T1 times the R negative plus the T2 times the R positive. And we can extend this equation to be like that. Now we have the two equations. If I'm going to write down one above the other and we start to add them, you can see that this one is negative, it was positive on the other side. This one is positive, was negative on the other side. And this value is positive on both ends. So we're going to add this value to be times 2. And on this side, we're only going to have the integration from 0 to 3 of the 12t dt. So by adding both equations, we're going to come to this result. Okay, so we know that actually we add them, but the omega 2 is A is equal to omega 2b. This can be 2 omega directly. Don't worry about that. We continue with the integration. We're going to have the 12 multiplied by t squared divided by 2. Okay, and we're going to have the 6t squared from 0 to 3. And this will be equal to the 0.2344 times the omega A2 plus the omega B2, which are the same. So we can simply say that 54 is equal to 0.2344 multiplied by 2 omega. So for the omega, and we're going to find that the omega 2 is going to be equal to 115 radian per second. And that's what we're going to have for both disks. So once again, simplify the question and you will get the answer directly. Thank you very much. And next, we're going to start with the week 9 tutorial and post.